has nothing to do with Unit 6. It's a pretty big skill. I see 3 equations. One of those is really easy to solve for a variable. The middle one. If you take the middle one and solve it for z, what do you know z is? -5. You can't make a sign mistake. Make one sign mistake, the rest of it's all wrong. Now, the equation down low has x's and y's but no z's. The equation up top has x's and y's and z's, but you know what z is. What can you do with it? Plug it in. So I'll do that because when I do that, the resulting equation will have no z's. So 5 negative 5s makes a negative 25. You counteract subtraction through addition. Negative 21 plus 25 is 4. And I get this equation, 2x plus 3y equals 4. What's that, Stephen?
Oh, bad math.
Now, Devin's right, elimination method. I'm going to line up this 6x minus 3y equals 0 with that equation. How'd you do that? You added them. You add down. If you add down, there's 4 x's. There are no y's. Divide out the 4, and what's your x value? 1. So now you know x, you know z, and you can get y by plugging into an equation, right? I don't guess it matters which one you do. I'm going to go take it and put it in that one. So negative 2 times a 1 plus 3y is a 4. Negative 2 times 1 is negative 2. You counteract the subtraction through addition. 3y is 6, and y is 2. Alright, so we found that x is 1, y is 2, and z was negative 5. Now, answers to systems equations like this are presented in what you call an ordered triple. An ordered triple is written x, y, z. It's like an ordered pair, it's an ordered triple. So it'd be 1, 2, negative 5. A lot of times you'll see multiple choice questions that have these things out of order. Right answers, it might be 2, 1, negative 5, just out of order. Because sometimes kids don't understand that things are in alphabetical order. They see a 2 and they see an answer choice to 2, that must be it. And that was number 3. And by the way, you can do every bit of that in TI-84. Tells you where to look. Factoring. I think there's only 3 or 4 factoring questions on the actual quiz. This is a fat twin. It's got a lot more on it than the actual quiz has. So let's do some factoring. How do you factor 9x squared minus 36? All right, so Devin says 3x minus 6 and 3x plus 6. Devin, I would take points off. He hasn't, he's right. That is, sorry, he said plus. No, this is partially factored. What are each of the 2 terms divisible by? This is the long route. What's 3 times 3? I know, I'm just showing that Devin could have gotten the right answer. There's always more than one way. This is the right answer. But had you pulled a 9 from the get-go, you would have had x squared minus 4. And I know some of y'all struggle with that because you don't look at numbers and realize what they're divisible by. That's your weakness. Now, how does x squared minus 4 factor? See, one way is a lot quicker. When you factor, kids. All of it. As big as you can. Now, I know a lot of you guys didn't realize that's how it factors. It's because you never memorized the pattern a squared minus b squared. That's what it boils down to. Now, you guys have access to Khan Academy. There's factoring in that thing. Do it. I know it starts off easy, but then you have to level up on it. Z squared minus 10n plus 9. You seek factors of 9 that get you to what? Negative 10. What are factors of 9 that will get you to negative 10? Negative 1 and negative 9. Z minus 1, Z minus 9. Because the outside, or the last, makes negative 1 times negative 9, positive 9. Negative 9 on the outside, negative 1 on the inside, that's negative 10. That's simple factoring. 6 looks a little harder, but it's really not. There's only one way to get to a 7n squared. What is it? 7n and n. You got to play with factors of 60. That's kind of rough. What's your gut say? When you see 60, what's the first thing pops in your head? 6 and 10. 6 and 10 should be the first thing that pops in your head when you see 60. That's weird. You should have been taught how to count by tens when you were a kid. Did they not do skip counting with you, or they went 10, 20, 30, 40, 50, 60? That's counting by fives, but yes. Anyways, when you see 60, your gut ought to say 6 and 10. What's the outside make? 42. What's the inside make? 10. What's the goal to get to? 32. So that's negative, that's positive, because that makes a negative 42, that makes a plus 10. Negative 42 plus 10 is negative 32. G is factored. These aren't solved either, they're just factored. All right, so you up the difficulty a little bit. You put a funny exponent. There is a typo on this thing too. That should be 5x to the n. It should be x to the 2n minus 5x to the n plus 6. Now, if Aaron has paid attention as we've gone over homework a couple times. Hobo, how do you make an x to the 2n? Yep. Aaron said it. Look. X to the n is x to the 2n. We've done that with homework review, kids. So how's this thing start in both sets? X to the n. Again, there was a typo. I corrected that. Factors of 6 that get you to what? What are they? Negative 2 and negative 3, Devin. Negative 6 and positive 6 and negative 1 product is negative. They have to add negative 5, but have a product of positive 6. That's an easy mistake to make. 8's not really that bad. I know that kids see those higher exponents, they get a little scared of them, but how do you create x to the 4th? Takes an x squared. It's actually a really easy problem. Then you need factors of negative 4 that gets you negative 3. 4 and 1 is what you're going to use. One of them is negative. Which one? Are you done? No. Does x squared plus 1 factor? No. There is no such thing as a sum of two squares. This is an a squared minus b squared pattern. That is a pattern that exists. Something squared minus something else squared. How does something squared minus something squared factor? That's right. Both of you. Theron told me the pattern. You told me how it factored. That's x plus 2 and x minus 2, or vice versa. It doesn't matter which one comes first. There's the complete factorization. All right, you look at 9. How many pieces does 9 have? 4. So what do? You cover up. What can you pull from a 12xy and a 28x? A lot more than x. A lot of 4.
Pull 2.
If you can pull a 4, you can pull a 2. Why not pull the 4? Can't pull an 8.
7, God bless.
Can't pull a 7.
7 times 4 is 28.
But it's 7 times what is 12? The answer to that's 12 sevens.
Oh, no, you pull a 4 of the same, you just left in 7.
Wait, as I pull a 4x from 12xy, what's left?
3.
3y minus 7.
That's not 7.
Now, whatever happens, this piece has to be recreated. You have to recreate 3y minus 7. What do you pull from a negative 15y to become a positive 3y? Pull the negative 5. I've talked about that. When there's a negative in between those pieces, you almost always pull a negative. And does it work? Is negative 5 times 3y a negative 15y? Is negative 5 times negative 7 a positive 35? All right, so you went from 4 things to 2 things. What do they both have in common? 3y minus 7. You pulled it from 4x times 3y minus 7. 4x is left. You pulled it from the back. What's left? It's the crap left over. 10. What kind of pattern is 10? Sum of 2 cubes. It is an a cubed plus a b cubed. And how does a cubed plus a b cubed factor? That's a hard part for a lot of y'all memorizing. How do you figure out what a is? Take cubic roots. A is the cubic root of 8x cubed. It's more than 2. It's 2x. The cubic root of 8 is 2. The cubic root of x cubed is x. B is the cubic root of 27, which is 3. And then you just plug into this formula, kids. It's a 2x plus a 3. What are you supposed to do with a here? Square it. What's a 2x times a 2x? If you write 2x squared, it's wrong. What's 2x times 2x? 4x squared. Take away the product. What's 2x times 3? Notice I'm just paying, these signs matter, not whatever you think matters. It's these signs that matter. And what do you do with that 3? What do you get? You get 9. That's the sum of 2 cubes. The next one is actually a difference of 2 cubes. And I'm going to rearrange it. Makes it more apparent. Is 125 a cube? Yep. Is 27u cubed a cube? Yep. All right, we need to pick out a. A is the cubic root of 125, which is 5. B is the cubic root of what? What's B the cubic root of? It's the cubic root of 27u cubed. A lot of you don't write it down, and like you'll do something stupid like say B is negative 3u. The only signs that matter are the signs given in the forms when everything's said and done. Stephen, you just taking them great notes back there, aren't you? What is the cubic root of 27u cubed? 3u. Now, last thing to talk about, the difference of 2 cubes pattern. What is it? Oh, it's just theorem this time. It's a minus b. Lettering's all the same. It's the signs that change between the 2 forms. You just got to plug in, kids. I know this looks kind of weird because I changed the order of the equation, but a is 5, isn't it? 5 minus 3u. What's it say I do with that 5? It's 5 squared. 25. Plus, because there's a plus on the form. What am I supposed to do with 5 and 3u? Multiply them. And lastly, what am I supposed to do with this 3u? What's a 3u all squared? If you write 3u squared, it is wrong. Unless you're using parentheses properly. Even then, I'd probably still dock off because you stopped when you could keep going. All right. You guys are going to have to memorize your patterns, part of it. And number 12. What can you do? How? Same simplification. It's called factoring. Like you can't just go through and divide by 2. There's no equal sign. This is an expression, not an equation. What can you pull? Can you pull an x? It's a good place to start. Are both numbers even? It's another good place to start. So pull how many x's? Pull 2 x's. There's a reason you only pull 2x, by the way. If you pull 2 from 250, what's left? 125, x to what power? Third. You pulled an x from x to the fourth. If you pull a 2x from 128x, what's left? 64. And you created something. You created a pattern. What pattern is that?
AQ plus BQ.
That's AQ plus BQ.
And then A squared minus AB plus B squared.
What's A? A is 5x. Because a 5x times a 5x times a 5x is 125x cubed. What's B? B is 4. 4 times 4 times 4 is 64. Always has been, always will be. So this little piece has to be carried down. And the pattern, if you took your notes, is off to the left. What's the first factor? A plus B, so 5x plus 4. What are you supposed to do with your 5x? Square it.
25, A squared.
What are you supposed to do with 5x and 4? Multiply and subtract, so minus 20x. And lastly, what do you do with that 4? Plus 16. There's your full factorization. I did put a quadratic formula on here. You're in Algebra 2. If you can't do the quadratic formula, I don't know what you expect. What is a quadratic formula? Oh, man. What's wrong? Somewhere else. Jace, what you doing back there? Trying to entertain yourself, what you're trying to do. Anyways, kids, I realize you don't like this, but you're all flunking me. So whatever you're doing, just keep doing it, and what is going to happen? You're going to fail. You know this. What's B? B is negative 12. What's A? A is 5. What's C? 6. Now, you know, a lot of times when I do stuff up with you guys, I'll pull numbers. Could you pull anything from 5, 12, and 6? No, it's as reduced as it gets. So you just plug into that thing. Opposite of negative 12 is 12. Plus or minus. You guys are sadly going to use a calculator for a lot of this. You have a negative that you're going to square, and if you're going to use technology, what do you have to wrap it in? If you don't, it's wrong, and you know you're making that mistake. So quit making it. Minus 4 times A, which is 5, times C, which is 6. All sitting over twice an A, so twice a 5. Nope. Never has, never will. Because if you square a negative, what happens? It becomes positive. I just don't show that. What happens is if you show kids that you can throw away the negative here, they throw it away up front. So I don't ever show it.
24 and radical.
What's in there, 24? That's right. So x equals 12 plus or minus a root of 24 over 10. So here comes a freshman algebra skill, simplification of the radical.
What is it, negative 4?
No, it's positive 12, son.
X is negative.
X is positive 12. B was negative 12. The formula says opposite B. Becomes positive 12. Anyways, the freshman skill, the root of 24. How do you get there? 4 and 6. 2 root 6. So I plug that in. You could have no access to the radical. Pretend it doesn't exist for a minute. 12, 2, and 10 are all divisible by what? 2. 12 divided by 2 is 6. 2 divided by 2 is 1, understood to exist. 10 divided by 2 is what? 5. That's one way of writing it. I would also take 6/5 plus or minus root 6 over 5. I don't care which one you give me. Just simplify the radical. Let's see if I got enough time to do another one. Yeah, I do have enough time to do one more. Before the day's over, I'll have all this done. You can watch a video if you want. All right, let g of x equals 3x times x plus 3 times x minus 4 all squared times x squared plus 7 cubed. Find the real zeros, your x-intercepts, and state their multiplicity. Now, x-intercepts happen when y is what? This is becoming a 0. That's what's happening. That is becoming a 0. You use the cover-up method. 3x is 0. What's x? 0. What's the exponent at x? 1. It's the first power. Multiplicity is 1. That 0 happens one time. Again, cover-up method. I have an x plus 3 equal to a 0. What's x? Negative 3. What's the exponent on that parentheses? 1. Multiplicity is what? 1. Happens one time. Here I have x minus 4 equals 0 because I'm using the cover-up method. What's x? 4. What's the exponent on the parentheses? 0 happens twice. It's what we call a touch on a graph. The last one is x squared plus 7 equals 0. Subtract 7, and you should stop. If you know anything about math and you read the question, you stop. Why? It's not real. It is not real. I'm only asking for real zeros. And I'll stop there, and I'll get the rest of this done in the other class. So, you'll have a video up. You're not going to take the test till Thursday, so either I'll let you work on this tomorrow, or I'll have a different twin. One of the two. Tomorrow you'll be working, though. I'm not going to work it out with you.